and welcome to Group D's explanation of what ATP synthase is. Now here, we have a young man named Billy. Billy is 20 years old, of Roma ethnicity, and his parents happen to be siblings. Billy, one day, is going for a run, and he collapses. He gets rushed to the emergency room, and we find out that he has some sort of ATP synthase deficiency. And here's a closer look at ATP synthase. ATP synthase is composed of two subcomplexes, the F0 embedded in the lipid bilayer of the inner membrane of the mitochondria, and the F1, which is located in the mitochondrial matrix. The central part, or the central stalk, consists of the gamma subunit, which helps to rotate the entire molecular machine. And then we have the peripheral stalk, which is the B subunit, or also known as the stator. ATP synthase functions to convert ADP and PI into ATP. And here's a more in-depth look at the F0 subcomplex of ATP synthase. It's composed of the A, B, and C subunits, and also others. The A functions to contain the two proton half channels. Each half channel will have a proton come in, and there's a conserved glutamate here that attracts those protons. And the C ring rotates around to a conserved arginine, where this arginine pushes the protons out the other half channel of the peripheral stalk. And here we're going to take a closer look at the F1 subcomplex of ATP synthase. So the F1 is connected to the F0 via the peripheral stalk and the central stalk located right where I am. And the gamma subunit of F1 is the only subunit that rotates. Otherwise, there are 6 different subunits, 3 non-catalytic alpha subunits, and 3 catalytic beta subunits that alter conformations as the gamma subunit rotates to produce the ATP. So in one of the catalytic sites, or one of the beta subunits, you have ADP plus PI bound. And once I rotate towards it, it converts into ATP. In one of the other sites, we have a bound ATP. It's very tightly bound in this site and will remain here as I once again rotate to where we have an ATP that is ready to be released. So we suspect that Billy has a mutation in his mitochondrial DNA, which is heteroplasmic, meaning that he has different genomes within the organelle that produce the mitochondria. And this led to an improper assembly of ATP synthase. This improper assembly of ATP synthase led to ATP synthase with deficiency, which often causes things such as cardiomyopathy. And this cardiomyopathy is what ended up causing him to collapse.